On March 3, 1943, in the Bismarck Sea north of New Guinea, American B-25 Mitchell bombers attacked a Japanese convoy with a new and devastating tactic. Flying at masthead height, so low that pilots could see the faces of Japanese sailors, the bombers raked ships with concentrated forward-firing machine guns and cannons before releasing bombs that skipped across the water like stones and slammed into ship hulls at the waterline. The results were catastrophic for the Japanese. In 3 days of attacks, the convoy was annihilated. 8 transports and 4 destroyers sunk, with approximately 3,000 Japanese soldiers killed. The American losses were negligible. 1 bomber shot down, 1 damaged. It was one of the most lopsided aerial victories of the Pacific War. The tactics and modifications that made this victory possible were largely the work of one man. Paul Irvin "Pappy" Gunn, a former Navy pilot, airline mechanic, and Philippine civilian who had joined the Army Air Forces after escaping from the Philippines. Gunn wasn't an engineer or a designer. He was a hands-on mechanic with an instinctive understanding of what made aircraft deadly in combat. Working in primitive conditions with salvaged parts, limited tools, and no official authorization, Gunn transformed medium bombers into low-level strafers capable of destroying ships and ground targets with unprecedented effectiveness. He pioneered skip bombing tactics, designed field modifications that increased aircraft firepower by 500%, and solved critical technical problems that saved countless lives. His innovations changed the nature of air combat in the Southwest Pacific and influenced aircraft design for decades to come. Yet for years, his story was known only to the pilots who flew his modified aircraft and the mechanics who helped him work miracles in jungle workshops. This is the story of Pappy Gunn, the mechanic who became one of the most important figures in Pacific air warfare, the man who turned bombers into tank killers and ship destroyers, and the father who fought a war to find his family trapped behind enemy lines. Paul Irvin Gunn was born on October 18, 1899 in Quitman, Arkansas. He grew up in an era when aviation was still in its infancy. The Wright brothers had made their first flight just 6 years before his birth. But by the time Gunn reached adulthood, aircraft were evolving from curiosities into weapons of war. In 1917, as America entered World War I, Gunn enlisted in the U.S. Navy and trained as a pilot. He earned his wings and served as a naval aviator, though the war ended before he saw combat. This early flight training gave Gunn both piloting skills and, critically, hands-on experience with aircraft maintenance and repair. Naval aviation in the 1910s required pilots to be part mechanic. If something broke, you fixed it yourself. After leaving the Navy in 1919, Gunn struggled to find his place. Aviation jobs were scarce in peacetime America. He worked various jobs, got married to Ruth Mabry in 1922, and started a family. But Gunn was drawn to flying and to adventure. In 1927, he saw an opportunity. Philippine Airlines was looking for experienced pilots. Gunn moved his family to the Philippines and began flying for the airline. The Philippines offered adventure, decent pay, and the chance to fly regularly. Gunn became chief pilot and chief mechanic for the airline, responsible for both flying passengers and keeping the company's aging aircraft operational. This dual role was perfect for Gunn's talents. He was an excellent pilot with thousands of hours in all conditions, but he was an even better mechanic. Intuitive, creative, and willing to improvise solutions with whatever materials were available. In the Philippines, far from manufacturer support, Gunn learned to keep aircraft flying using salvaged parts, local materials, and ingenuity. By 1941, Gunn had been in the Philippines for 14 years. He and Ruth had 4 children: Nathaniel, born 1924, Julie, born 1927, Connie, born 1929, and Paul Jr., born 1935. The family had a comfortable life in Manila. Gunn was well known in Philippine aviation circles as an exceptional pilot and mechanic. Then, on December 8, 1941, December 7th in Hawaii, Japan attacked the Philippines. Everything changed. The Japanese attack on the Philippines came hours after Pearl Harbor. Japanese aircraft bombed American airfields, destroying much of the U.S. Far East Air Force on the ground. Within days, Japanese forces were landing on Luzon, the main Philippine island. Gunn's first priority was his family. He tried to evacuate them, but the chaos of the Japanese invasion made this impossible. The Japanese were advancing rapidly. Manila would soon fall. Gunn faced an agonizing choice: stay with his family and likely be captured, or escape to continue fighting with some hope of eventually liberating the Philippines and rescuing his family. Ruth made the decision for him. She insisted he go. She would take care of the children. He needed to fight, to do whatever he could to help defeat the Japanese and free the Philippines. Gunn reluctantly agreed. In late December 1941, as Manila fell to the Japanese, Gunn escaped to Australia aboard one of the last aircraft to leave the Philippines. He had been separated from his family. Ruth and the 4 children were trapped in Manila under Japanese occupation. Gunn didn't know if he would ever see them again. The separation would last for 3.5 years. During that time, Gunn would pour all his energy into the war effort, driven by the hope that victory would reunite him with his family. But he would also face the constant fear that his family might not survive Japanese occupation, that they might be among the thousands of civilians who would die in prisoner-of-war camps. When Gunn reached Australia in early 1942, he was 42 years old, far too old for conventional military service, but his skills were desperately needed. The U.S. Army Air Forces in the Southwest Pacific had suffered devastating losses. Aircraft were in short supply. Mechanics and pilots who knew how to keep planes flying in primitive conditions were invaluable. General George Kenney, who would soon take command of the 5th Air Force, recognized Gunn's value immediately. Kenney was building an air force from scratch in the Southwest Pacific, scrounging equipment, improvising solutions, and trying to take the fight to the Japanese despite having inferior numbers and often inferior equipment. Gunn was commissioned as a captain in the Army Air Forces and assigned to the 3rd Attack Group, initially as a pilot, but quickly moving into a role where he could use his mechanical expertise. The 5th Air Force needed someone who could solve problems, modify aircraft for the unique conditions of Southwest Pacific combat, and do it all with limited resources and no time to wait for official authorization. Gunn was perfect for the job. He understood aircraft inside and out. He was creative and willing to try unconventional solutions. He didn't worry about following proper procedures or going through official channels. If something needed to be done, he did it. And he had powerful motivation. Every Japanese ship sunk, every Japanese aircraft destroyed, every tactical advantage gained brought the Allies closer to liberating the Philippines and rescuing his family. In early 1942, Allied air power in the Southwest Pacific faced a critical problem. Conventional bombing tactics were proving ineffective against Japanese shipping. The standard approach was level bombing, flying at altitude, typically 10,000 to 20,000 feet, and dropping bombs aimed at ships below. This method had several advantages. Aircraft were relatively safe from anti-aircraft fire, and bombardiers had time to aim carefully. But level bombing had a fatal flaw when attacking ships. It didn't work very well. Ships could maneuver, making them difficult to hit from altitude. The time it took for bombs to fall from 15,000 feet gave ships time to change course. Even skilled bombardiers struggled to achieve hit rates above 5%. This meant that out of every 20 bombs dropped, 19 would miss. The mathematics were brutal. To have a good probability of hitting a single ship, multiple bombers had to attack, each dropping multiple bombs. This required concentrating aircraft that were already in short supply, and even when ships were hit, high-altitude bombs often penetrated straight through a ship's deck without detonating properly, or exploded above the waterline where damage was less catastrophic. The Japanese were running convoys between their bases, bringing in reinforcements and supplies. Allied commanders needed a way to interdict these convoys, to sink the ships and prevent Japanese troops and equipment from reaching their destinations. Conventional high-altitude bombing wasn't getting the job done. Several approaches were being tried. Torpedo bombing was potentially effective but extremely dangerous. Torpedo bombers had to fly slow and straight during their attack runs, making them vulnerable to anti-aircraft fire. The U.S. Navy's torpedo bombers had suffered appalling casualties at battles like Midway. Dive bombing could be accurate, but required specialized aircraft and extensive training. The Southwest Pacific had few dive bombers and couldn't afford the losses they often suffered. What was needed was a new approach, something that would use the available aircraft, primarily medium bombers like the B-25 Mitchell and A-20 Havoc, but employed them in ways that were more effective than high-altitude level bombing. This is where Pappy Gunn came in. Gunn began experimenting with low-level attack tactics in mid-1942. The concept was simple but dangerous. Instead of bombing from altitude, aircraft would attack at masthead height, so low they were flying just above the waves, often at 50 feet or less. At this altitude, bombs released with forward momentum would skip across the water's surface like stones, bouncing once or twice before striking the ship's hull at or below the waterline. This skip bombing technique had several advantages. Accuracy. At low level, the target was much easier to hit. The bomber was close enough that aiming was more direct, and the bomb's trajectory was more predictable. Lethality. Bombs hitting at the waterline caused far more damage than bombs exploding above deck. A waterline hit could sink a ship quickly. Psychological impact. The low-level attack was terrifying for the ships being attacked. Bombers roaring in at wave-top height, so close that crews could see the pilots, created panic and disrupted defensive fire. But low-level attack also had a critical vulnerability. The attacking aircraft would be exposed to intense anti-aircraft fire from the ships. Medium bombers like the B-25 weren't armored or designed for low-level combat. They needed a way to suppress the anti-aircraft defenses while making their attack runs. Gunn's solution was to turn the bombers into gunships. Standard B-25 Mitchell bombers in 1942 had relatively light forward armament, typically 1 or 2 50-caliber machine guns in the nose, operated by the bombardier. This was adequate for high-altitude bombing missions where the aircraft rarely engaged in direct combat, but it was completely insufficient for low-level attacks, where the bomber would be flying directly toward heavily armed ships. Gunn proposed a radical modification. Install multiple .50 caliber machine guns in the nose of the bomber, all firing forward, controlled by the pilot. The bomber would become a flying gun platform, capable of suppressing anti-aircraft fire during the attack run. Working with his mechanics at Port Moresby and other bases in New Guinea, Gunn began modifying B-25s. The modifications were done in the field using tools and materials that were available without waiting for official approval or engineering drawings from the United States. The initial modifications added 4 forward-firing 50-caliber machine guns to the B-25's nose. Later versions added more, 6 guns, then 8, eventually reaching configurations with as many as 14 forward-firing 50-caliber machine guns, plus 4 par-150 caliber guns in side packages. The firepower increase was staggering. A standard B-25 might fire 200 rounds per minute forward. Guns' modified strafer versions could fire over 4,000 rounds per minute. More firepower than many fighter aircraft and enough to shred wooden-decked ships, destroy anti-aircraft gun positions, and kill exposed crew members. But installing the guns was only part of the challenge. The aircraft had to be able to handle the additional weight, the recoil forces, and the ammunition load. Gunn's team had to solve numerous technical problems. Weight and balance. Adding guns and ammunition affected the aircraft's center of gravity. Gunn had to carefully position the guns and ammunition to maintain proper balance. Recoil. Multiple heavy machine guns firing simultaneously created enormous recoil forces that could affect aircraft stability and even damage the airframe. Gunn designed mounting systems that could absorb the recoil. Ammunition supply. More guns meant more ammunition, which meant more weight and the need for feeding systems that wouldn't jam. Gunn designed reliable ammunition feeds that kept the guns firing. Electrical systems. The additional guns required electrical firing systems. Gunn modified the aircraft's electrical system to handle the load. All of this was done in primitive field conditions. Gunn and his mechanics worked in open-air workshops with tropical heat, frequent rain, and limited tools. They fabricated parts, adapted systems, and tested their modifications through trial and error. When official parts weren't available, they made do with whatever they could find or improvise. The first modified B-25 strafers underwent testing in late 1942. The results were immediately impressive. The concentrated firepower was devastating against ground targets and ships. Pilots loved the ability to suppress enemy fire during attack runs. But the testing also revealed problems that needed to be solved. Muzzle flash. When all guns fired simultaneously, the muzzle flash was so intense it could blind the pilot at night or in low light. Gunn had to design flash suppressors. Vibration. The sustained firing created severe vibration that made aiming difficult and could cause structural fatigue. Mounting systems had to be improved. Harmonization. The guns needed to be harmonized, aimed so that all bullets converged at a specific point. Gunn developed field procedures for harmonizing the multiple guns. Spent casings. The guns ejected thousands of spent shell casings during an attack. These casings could jam gun mechanisms or even damage the aircraft. Gunn designed ejection systems that safely disposed of the brass. Each problem was solved through experimentation and testing. Gunn would try a modification, test it, observe the results, and make improvements. This iterative process, conducted in the field without the resources of a proper engineering department, demonstrated Gunn's practical genius. The strafer modifications weren't limited to B-25s. Gunn also modified A-20 Havocs, B-26 Marauders, and other aircraft. Each type required different solutions, but the basic concept remained the same. Maximize forward firepower to enable effective low-level attack. Alongside the aircraft modifications, Gunn worked with combat pilots to develop tactics for low-level strafer attacks. The standard approach evolved into a carefully choreographed assault. The approach. Aircraft would approach the target at wave-top height, using the curvature of the Earth and the limited radar capabilities of the era to avoid detection until the last possible moment. The strafe. As the aircraft closed to effective gun range, typically 1,000 or 2,500 yards, all forward-firing guns would open fire. The concentrated stream of bullets would rake the target ship's deck, destroying anti-aircraft guns, killing exposed crew members, and creating chaos. The skip. Still firing, the pilot would release bombs at very low altitude, typically 200-300 feet above the water at a range of 800 to 1,000 yards from the target. The bombs, released with the aircraft's forward momentum, would skip across the water like stones. The breakaway. Immediately after releasing bombs, the pilot would brake hard left or right and climb, using the ship as a shield against other vessels in the convoy, while escaping the blast radius of their own bombs. The timing was critical. Pilots had to judge their release point perfectly. Too early and the bombs wouldn't skip properly. Too late and the aircraft might be caught in its own bomb blast or might not have time to break away before hitting the ship. The attacks were conducted in coordinated strikes. Multiple aircraft would attack simultaneously from different angles, overwhelming the convoy's defenses and ensuring that at least some bombs would hit, even if individual ships managed to evade. The ultimate test of Gunn's modifications and tactics came in early March 1943 at the Battle of the Bismarck Sea. Japanese forces were attempting to reinforce their garrison at Lae in New Guinea with a convoy of 8 transports and 8 destroyers carrying approximately 7,000 troops. Allied intelligence detected the convoy, and General George Kenney ordered a maximum effort to destroy it. The 5th Air Force would use its modified strafers and skip bombing tactics. This would be the definitive test of whether Gunn's innovations could deliver decisive results in combat. On March 2, 1943, waves of Allied aircraft attacked the convoy. B-25 strafers, many modified by Gunn himself, came in at masthead height. The results exceeded all expectations. Day 1. High-altitude bombers and strafers sank 2 transports and damaged others. Day 2. The strafers went to work in earnest. Flying at wave-top height, they raked the convoy with devastating gunfire before releasing skip bombs. One after another, ships were hit, bombs skipping across the water and slamming into hulls at the waterline. By the end of March 3rd, the results were catastrophic for the Japanese. All 8 transports sunk, 4 destroyers sunk, approximately 3,000 Japanese troops killed, 20 Japanese aircraft shot down. Allied losses were minimal. 1 bomber shot down, 1 bomber damaged, 2 fighters lost. The kill ratio was stunning. The strafer tactics and skip bombing technique had proven devastatingly effective. Ships that might have survived high-altitude bombing attacks were destroyed in minutes by low-level strafers. The Battle of the Bismarck Sea was a turning point in the Southwest Pacific campaign. The Japanese would never again attempt large-scale reinforcement by convoy in areas where Allied air power could reach them. The sea lanes around New Guinea and the Solomons became Allied-controlled territory, and Pappy Gunn's innovations had made it possible. While the strafer modifications proved their worth against ships, Gunn quickly realized the same approach could be devastating against ground targets. The concentrated forward firepower was ideal for attacking Japanese airfields, supply dumps, troop concentrations, and fortified positions. Gunn developed specific modifications for ground attack missions. Parafrag bombs. Gunn helped develop and deploy parafrag bombs, small fragmentation bombs with parachutes that allowed low-flying aircraft to drop them without being caught in the blast. These were ideal for destroying parked aircraft and personnel in the open. White phosphorus. Gunn's strafers were equipped to carry white phosphorus rockets and bombs, which created fire and smoke useful for attacking fuel dumps and supply areas. Increased ammunition capacity. For sustained ground attack missions, Gunn increased ammunition capacity, allowing strafers to make multiple attack runs without returning to base. The ground attack strafers proved as effective as the anti-ship versions. Japanese airfields came under devastating attack. Aircraft parked in revetments were destroyed, fuel dumps exploded, supply convoys were massacred. The psychological impact was significant. Japanese forces learned to fear the sound of approaching B-25s at low altitude. The distinctive sound of multiple 50-caliber guns firing simultaneously became associated with destruction and death. The unit that would become most associated with Gunn's strafer tactics was the 345th Bomb Group, nicknamed the Air Apaches. Arriving in the Southwest Pacific in mid-1943, the 345th was equipped entirely with B-25 strafers, modified by Gunn and his teams. The 345th specialized in low-level attacks against shipping and ground targets. Their tactics were aggressive to the point of recklessness, flying at altitudes where they could see the faces of enemy soldiers, pressing home attacks through intense anti-aircraft fire, and accepting risks that other units considered suicidal. The results justified the tactics. The 345th destroyed over 600 enemy aircraft, mostly on the ground, sank or damaged over 300 ships, and destroyed countless ground targets. They received 4 Distinguished Unit citations and numerous individual decorations, but the cost was high. The 345th suffered heavy casualties. By war's end, they had lost 177 aircraft and 712 men killed or missing. The low-level strafer tactics, while effective, were dangerous. Aircraft operating at masthead height had no room for error and no time to evade damage. Gunn, who flew combat missions with the 345th despite his age and non-combat role, understood the risks intimately. He continued to refine the modifications, adding armor protection in critical areas, improving gun reliability, and developing tactics that would reduce casualties while maintaining effectiveness. Gunn's contributions extended far beyond the strafer modifications. He was a constant source of innovation and problem-solving for the 5th Air Force. Fuel tank modifications. Gunn developed auxiliary fuel tank installations that extended range without requiring extensive aircraft modifications. This allowed fighters and bombers to operate deeper into Japanese-held territory. Armor installation. He designed field-expedient armor installations for vulnerable areas of aircraft, protecting pilots, fuel tanks, and critical systems without adding excessive weight. Emergency repairs. Gunn developed techniques for rapidly repairing battle-damaged aircraft using salvaged parts and improvised materials. Aircraft that would normally be written off were returned to service within days. Spare parts. Manufacturing. When official spare parts weren't available, which was often, Gunn's workshops manufactured replacement parts from raw materials or cannibalized damaged aircraft. Training programs. Gunn trained mechanics throughout the 5th Air Force in his modification and repair techniques, multiplying his impact across the entire theater. General Kenny relied on Gunn to solve problems that conventional engineering approaches couldn't handle. When something needed to be done quickly, with limited resources. In field conditions, Kenny turned to Gunn. Throughout the war, Gunn's primary motivation remained personal. Defeating the Japanese and liberating the Philippines meant rescuing his family. He didn't know where Ruth and the children were, or whether they had survived Japanese occupation. In fact, Ruth and the 4 children had been interned by the Japanese in early 1942. They were held at the Santo Tomas internment camp in Manila, along with thousands of other civilians. Conditions were harsh. Inadequate food, minimal medical care, overcrowding, and the constant threat of violence from guards. But Ruth and the children survived. They endured years of internment, malnutrition, and uncertainty. Ruth tried to maintain normalcy for the children, continuing their education as best she could and shielding them from the worst conditions. Gunn knew nothing of this. For 3.5 years, he lived with uncertainty. Every day brought the possibility of news, good or bad, about his family. The not knowing was its own form of torture. His response was to throw himself into the war effort with complete dedication. Every modification he made, every innovation he developed, every combat mission he flew brought the Allies closer to victory and brought him closer to learning his family's fate. Despite being in his mid-40s and officially assigned to technical duties, Gunn regularly flew combat missions. He believed that to properly modify aircraft, he needed to understand how they performed in combat. He also wanted to personally take the fight to the Japanese. Gunn flew missions over some of the most heavily defended targets in the Southwest Pacific. He participated in raids on Rabaul, Wewak, and other major Japanese bases. He flew strafe missions against convoys and ground targets. He accumulated hundreds of combat hours. His age and experience made him a valuable leader. Younger pilots trusted him. He understood their needs because he flew with them. When Gunn said a modification would work, pilots believed him because they knew he'd tested it in combat himself. Gunn was awarded the Silver Star for gallantry in action and the Distinguished Service Cross for extraordinary heroism. The citations describe him flying through intense anti-aircraft fire, pressing home attacks against heavily defended targets, and demonstrating exceptional skill and courage. But Gunn didn't fly for medals or recognition. He flew because he was a pilot at heart, because he wanted to personally contribute to defeating the Japanese, and because every mission brought him closer to the Philippines and his family. In January 1945, American forces landed on Luzon and began the campaign to liberate Manila. For Gunn, this was the moment he had been working toward for 3 years. His family was in Manila, presumably in one of the internment camps, if they had survived. As American forces approached Santo Tomas internment camp on February 3, 1945, Japanese guards fled. American tanks crashed through the gates. The internees were free. Among them were Ruth Gunn and her 4 children. They had survived, malnourished, traumatized, but alive. When the camp was liberated, they asked about Paul, not knowing whether he had survived the war. Within days, Gunn learned that his family was alive and free. The reunion, when it finally happened, was emotional beyond description. Gunn had fought for 3.5 years, had helped transform air combat in the Pacific, had risked his life repeatedly, all with the hope of this moment. The family was together again. The children barely remembered their father. Nathaniel had been 17 when they were separated, but Paul Jr. had been only 6 and had few memories of him. They had to rebuild relationships that the war had interrupted. But they were alive. They were free. And the mission that had driven Pappy Gunn through years of war was complete. After the war, Gunn remained in the Philippines for a time, helping with reconstruction efforts and reuniting with his family. He eventually returned to the United States and retired from the Air Force as a colonel in 1948. Gunn never sought publicity for his wartime innovations. He was a mechanic and pilot who had done his job as he saw it. The modifications and tactics he developed were means to an end, defeating the Japanese and rescuing his family, not achievements to be celebrated. As a result, his story remained relatively unknown outside the circles of 5th Air Force veterans and aviation historians. While other figures from the Pacific War became famous, Gunn remained in the background. But those who flew his modified aircraft never forgot him. The pilots of the 345th Bomb Group, the strafer crews who depended on his modifications, and the mechanics who learned his techniques all knew that Pappy Gunn had saved lives and helped win the war. Gunn died on October 11, 1957, at age 57. He was buried with full military honors. His obituaries mentioned his service but couldn't fully capture the scope of his contributions. Much of his work remained classified, and the full story of the strafer modifications wasn't widely known. Pappy Gunn's innovations had lasting impact on military aviation. Forward firing. Armament. Gunn's work demonstrated the value of concentrated forward firepower on bombers and attack aircraft. Post-war attack aircraft incorporated this lesson with designs like the A-1 Sky Raider and A-10 Warthog, featuring heavy forward armament. Low-level attack tactics. The strafer tactics Gunn developed influenced close air support doctrine. The concept of using heavily armed aircraft at low level to suppress defenses and destroy targets became standard practice. Field modification. Gunn proved that field modifications, when properly conceived and executed, could be as effective as factory designs. The military became more open to field expedient solutions to combat problems. Skip bombing. While skip bombing was eventually superseded by guided munitions, the principle, using the weapon's trajectory and the target's environment to increase accuracy, influenced later precision attack techniques. Mechanic as innovator. Gunn demonstrated that hands-on mechanics with combat experience could solve problems that engineering departments couldn't. The military learned to value practical innovation from non-traditional sources. What made Gunn's story remarkable wasn't just the technical innovations, it was the human element. Gunn was a man fighting a war with deeply personal stakes. His family was in enemy hands. Every day of the war, he lived with the uncertainty of whether they were alive. This personal motivation drove him to extraordinary efforts. He worked longer hours, took greater risks, and pushed harder than might be expected of someone in a technical role. His innovations weren't just professional accomplishments. They were expressions of love for his family and determination to rescue them. The fact that his family survived, that he was reunited with them, gave his story a happy ending that many wartime stories lack. But it's important to remember that for 3.5 years, Gunn didn't know whether that ending would come. He worked and fought on faith and hope. Gunn's contributions can be compared to other great military innovators. John Boyd, fighter tactics. Like Boyd, Gunn understood combat from the operator's perspective and developed tactics that worked in real conditions. Kelly Johnson, aircraft design. Like Johnson, Gunn could see elegant solutions to complex problems and implement them quickly. Chuck Yeager, test pilot. Like Yeager, Gunn tested his innovations himself, flying combat missions in aircraft he had modified. What distinguished Gunn was that he did all of this in field conditions with limited resources while war was ongoing. He didn't have the luxury of test facilities, engineering departments, or development time. He had to make things work immediately with whatever was at hand. In recent decades, Gunn's story has received more attention. Books about the 5th Air Force and the Southwest Pacific Campaign have highlighted his contributions. Veterans organizations have honored his memory. Military historians have recognized him as one of the key figures in Pacific air warfare. In 2004, the book Pappy Gunn, The Unofficial Father of the 5th Air Force by Lawrence Cortese, brought Gunn's story to a wider audience. The book detailed his innovations, his combat service, and his personal story of searching for his family. Aviation museums have displayed examples of Strafer aircraft modified according to Gunn's designs. Educational materials about Pacific War aviation include his innovations. His name is now known among military aviation enthusiasts and historians. But this recognition came decades after his death, long after his contributions had been made. Gunn never sought fame, never promoted himself, and never tried to capitalize on his wartime achievements. He was content to have done his job and to have been reunited with his family. Several important lessons emerge from Gunn's story. Practical experience matters. Gunn's hands-on experience as a mechanic and pilot gave him insights that theoretical engineers might miss. Necessity drives innovation. The desperate circumstances of early Pacific War, aviation forced creative solutions. Gunn thrived in this environment. Field modifications can work. Given proper expertise and execution, field modifications can match or exceed factory designs. Personal motivation powers achievement. Gunn's determination to rescue his family drove him to extraordinary efforts. Leadership means leading from the front. Gunn's willingness to fly combat missions in aircraft he modified gave him credibility and understanding. Simple solutions to complex problems. Gunn's innovations were elegant in their simplicity. Add guns, fly low, skip bombs. The execution was complex, but the concepts were straightforward. Paul Irvin Pappy. Gunn was a mechanic who became a legend. Working in primitive conditions with limited resources, he transformed medium bombers into devastating low-level attack aircraft. His modifications and the tactics developed to employ them changed the nature of air combat in the Southwest Pacific. The Strafer aircraft Gunn created destroyed hundreds of Japanese ships, thousands of aircraft on the ground, and countless ground targets. The Battle of the Bismarck Sea, fought largely with his modified aircraft and tactics, was one of the most decisive aerial victories of the Pacific War. The 345th Bomb Group and other units equipped with Gunn's Strafers compiled devastating combat records. But Gunn's story is about more than tactical innovation. It's about a father fighting to rescue his family, a mechanic who saw problems and solved them, and a pilot who led from the front despite being well past the age when most men flew combat missions. His family survived. They were reunited, and the modifications and tactics Gunn developed helped bring the war to a successful conclusion sooner than it might otherwise have ended. Pappy Gunn never sought recognition for his achievements. He was a practical man who saw what needed to be done and did it. But those who flew his aircraft, who benefited from his innovations, and who studied his contributions to Pacific air warfare, understood his true importance. He was the mechanic who turned bombers into tank killers and ship destroyers. He was the innovator who worked miracles with salvaged parts and improvisation. He was the father who fought a war to find his family. He was Pappy Gunn, and his legacy endures in the history of military aviation and in the countless lives saved by his innovations. In the primitive workshops of New Guinea and the Philippines, working with hand tools and determination, Pappy Gunn changed how air war was fought. His modified B-25 strafers became symbols of American air power in the Pacific, feared by the Japanese, beloved by Allied pilots, and instrumental in achieving victory. That is the story of Pappy Gunn, mechanic, pilot, innovator, father, and one of the unsung heroes who helped win World War II in the Pacific.